We're going to continue with section 10.1, graph y equals ax squared plus c, part 2. Here we go. First, we're going to start off with a little review where y equals ax squared, where a is greater than 0. And now here, if we start off with a is greater than 1, so a could be 3, it could be 2, as long as the number is greater than 1, right, we would have a vertical stretch where the graph or the lines of the parabola are closer together. The blue, where a equals 1, would be the parent graph. And then here where it's saying 0 is less than a is less than 1, a could be, let's say, 1/2. And that would mean a vertical shrink where the wings of the parabola are farther apart than the parent graph. So again, we have a vertical stretch if a is greater than 1, and we have a vertical shrink if a is greater than 0 and less than 1. Next, we are going to move on to y equals ax squared, where a now is less than 0. And we're going to start with the example a is less than -1. And for example, a could be -2. Any number that is less than -1, it could also be -3, -4. Notice how our red parabola opens down. It reflects across this x-axis here. It's reflecting across the x-axis compared to the red parabola over here where it opens up. Now we are opening down. There's also a vertical stretch happening because the wings of our parabola are closer together than our wings of the blue parabola, where the blue parabola is our parent graph, or it would be a is equal to -1. And then finally, for the green parabola, we have -1 is less than a, and a is less than 0. So for example, a could be a -1/2, where the negative makes it open down or reflect across the x-axis, and our wings are wider than the blue parabola, so therefore it is a vertical shrink. So a vertical stretch with a reflection in the x-axis is where a is less than -1, and a vertical shrink with a reflection in the x-axis if -1 is less than a is less than 0. And then finally, our last example is y equals x squared plus c. We're going to start again with c is greater than 0, so c could be any number that is greater than 0. We'll go with 3. So if c was 3, it would move our parabola up 3 on the y-axis. All right? It would start where the blue parabola is, our parent parabola, and move it up 3. Again, c equals 0 is our parent parabola, and then for our green, c is less than 0, so we could pick any number less than 0. Let's go with -3. It would move it down 3 on our y-axis. All right, it would cross the y-axis right there. So an upward vertical translation would be c is greater than 0, and a downward vertical translation would be c is less than 0. And finally, everybody's favorite word problem. You can go ahead and read it, and I'll read it for you. A cross-section of the parabolic surface of the antenna shown can be modeled by the graph of the function y equals 12,000 x squared, where x and y are measured in meters. So part A, find the domain of the function. Well, the domain, remember, is our x values. So looking on here where we can barely see our x-axis, so we're going to see how big the x-axis is first. And so let's see what we have here for numbers. Here we have a 24, and this 24 is on the third coordinate. So I know that if I divide 24 by 3, because I have 3 coordinates, they're going to go by 8. So it's going to be 8, 16, 24, 32. So my biggest, where my, see if I can get it here. where the antenna ends at 32. So I know that my domain x is going to be less than 32 because there is no x value. The antenna is not going past 32. And now if we go the other direction, we're going -8, -16, -24, and we're going to end up here at -32 because the antenna does not go past where it does not go past x is -32. So now that I know that, I have x is greater than -32. And if I want to write this as a compound inequality, I'm going to put -32 on the left with a less than sign, less than x, and x is less than 32. Now I have my x values. Part B now asks me to find the range of the function, where the range of the function now is my y values. Well, I found my x values for part A, so I'm going to go ahead and plug my biggest x value into this x. So I'm going to come up with, and I'm going to write it out for us, 0, whoops, that's an ugly point, 0.012 times 32 squared. Now if you plug that into your calculator, you will come up with a positive 12.288. So that's my biggest value for my y because I plugged in my biggest value of x into x. So this is going to be my biggest y value. Well, I know that if I plug -32 in for x, I'm going to get the exact same thing because -32 times -32 is the same thing as +32 times +32. So now instead of plugging any negative numbers in, I am going to plug 0, x is 0, in for x. I'm going to plug 0 in for x, so I'm going to go 0 times 32 squared, and I know anything times 0 is 0, so now the range of the function, my lowest number could be possibly 0, or is possibly 0, and 0 is less than, y is less than or equal to 12.288, and it could also be 0, so I need a less than or equal to sign here. And that does it for 10.1.